This video, we're going to prove the following fact. If every prime that divides n also divides m, then phi of nm is n times phi of m. Before we get into the proof, I'm going to ask you nice folks to please think about subscribing to my channel if you haven't already, especially if you like watching mathematical proofs. That's what we do here on this channel. How about we get into the video? So, let's see. Let n equal to p1 to the k1 times p2 to the k2 up to pr to the kr. So the primes that divide n are p1, p2 up to pr, but they also must divide m. This implies that, well, let me not say imply. And m is equal to p1 to the l1 times p2 to the l2 all the way up to pr to the lr, and there's no reason why you can't have other primes. q1 to the m1 up to qs to the m sub s. By design, every prime that divides n also divides m. Okay. So what is phi of nm and what's n times phi of m? Well, phi of mn, well, what is mn? So it's going to be p1 to the k1 plus l1. That's what you get when you multiply those two times p2 to the l2 times p sub 2 to the k sub 2. That's p2 to the k2 plus l2 all the way up to p sub r to the k sub r times plus l sub r times this, the q's. q1 to the m1, q2 to the m sub 2, all the way up to q sub s, m sub s. Now, what does this equal? Well, this is p1 to the k1 plus l1 times 1 minus 1 over p sub 1 times this, phi of this, which is p sub 2 to the k sub 2 plus l sub 2 power times 1 minus 1 over p2, all the way up to this last one for the p's. We get p sub r to the k sub r plus l sub r times 1 minus 1 over p sub r times this, q1 to the m1 times 1 minus 1 over q sub 1, all the way up to q1 to the ms times 1 minus 1 over q sub s. Now, can we factor out n from this? The answer is yes. N has their k exponents. So from here, I can factor out p1 to the k1. From here, I can factor out p2 to the k2, all the way up to pr to the kr. And what's left from this will be p1 to the l1 times this, 1 minus 1 over p sub 1, times, we factored out p sub 2 to the k2, so we have p sub 2 to the l sub 2 times this, 1 minus 1 over p sub 2. Let me just move this over a little bit. Okay, so to save some space, how about we just jump up to the last one? We have PR to the L sub R times 1 minus 1 over P sub R. That's this, times all of that. Q1 to the M times 1 minus 1 over Q1 all the way up to Q sub S to the M sub S, that should be M sub 1, times 1 minus 1 over Q sub S. Well, clearly that's N. But you know what? That really is phi of M. That is, we did get N times phi of M. Phi of M. And that's exactly what I set out to prove. If you like watching videos like this, you should seriously consider subscribing to my channel, as this is what we do here. We prove mathematical facts. Please subscribe to my channel, click the like button, ask your friends and family to subscribe, or at least to view my videos. See you guys in the next video. Please watch and learn.